Organizations are pouring millions of dollars into highly sophisticated enterprise resource planning platforms and AI systems, yet they continue to operate on razor-thin margins. Despite the investment, readers remain blind to the critical shifts occurring in their own supply networks. This blindness persists because of a systemic enterprise data readiness failure that no amount of software can override. The modern enterprise suffers from a data readiness gap. Their data is physically trapped in silos, highly inconsistent across departments, or simply too out of date for an AI model to evaluate effectively. Resolving this blindness requires a clear architectural roadmap. Organizations must diagnose and repair 5 distinct structural failures within their data infrastructure. This diagram shows those 5 gaps: fragmented interoperability, the byproduct mindset, disjointed shipping data, isolated analytics, and slow-moving insights. Systematically fixing these 5 structural flaws is the mandatory prerequisite for transitioning from a blind, reactive system to an autonomous, high-velocity operation. The first hurdle is interoperability. Disparate enterprise systems, from legacy internal networks to third-party carrier portals, refuse to speak the same language. This creates conflicting versions of the truth that change entirely depending on which department you ask. IT departments often try to bridge this divide with simple API connections. An API, or application programming interface, is a set of rules that allow 2 software components to communicate. But an API only moves information. It cannot reconcile data that follows different logic. This diagram illustrates why true interoperability fails. 3 data streams crash into bottlenecks caused by a lack of universal standards and strict compliance laws. The bridge is further restricted by complex security requirements, needing massive IT budgets to maintain integration. Even if data crosses over, organizations lack shared semantic understanding to interpret it. Solving this requires a robust digital framework, functioning as a universal translation layer, mapping every data stream to a single internal standard with unified security. Without standardizing interoperability through this framework, advanced AI models will only amplify the existing chaos of siloed departments. The second gap stems from a historical architectural flaw. Supply chains have treated their data strictly as a byproduct, or exhaust, generated by their enterprise software applications. This byproduct mindset structurally traps critical information inside isolated operational silos. These functional systems were never designed to synergize with one another. Executives must initiate a strategic shift, treating data as a high-value, independent corporate asset. Critical enterprise data must extract itself, living completely independent of the software applications that originally created it. Establishing this independent, data-centric layer enables entirely distinct enterprise departments to finally operate from a single, verified source of truth. Decoupling data from localized software is the non-negotiable architectural foundation for organizational agility and technological innovation. The third gap involves a severe linking challenge. Shipping data naturally fragments across order fulfillment, transportation management, and financial systems. Relying on disconnected reference numbers causes linking to break, blinding systems and analysts. The solution is a universal shipper-originated load ID. This unique number remains attached to a shipment from planning through to final payment. This universal load ID integrates finance and planning directly into the live operational flow of the supply chain. With a load ID in place, a physical shipping delay is instantly recognized for its exact financial impact, and its ripple effect on future inventory planning is calculated immediately. Replacing these fragmented reference numbers with a single universal load ID transforms reactive troubleshooting into proactive end-to-end management. The fourth gap focuses on analytics. When underlying data is chaotic, business intelligence dashboards are restricted to merely reporting isolated history, telling you what already happened. Because of this, planners are forced to guess future outcomes by piecing together entirely disjointed datasets. Data must support a unified 6-tier analytics matrix. It begins with descriptive and diagnostic analytics for history, it advances to predictive and prescriptive analytics for foresight, and culminates in real-time and AI-powered analytics for ultimate autonomy. Generating decision-ready insights across this entire spectrum is strictly impossible without first curing data chaos. Traditional decision making relies on slow motion analysis and reports arriving days late. In a market moving at algorithm speeds, this represents a systemic failure. Executive intuition is a powerful tool, but it is currently being starved of the rapid, on demand insights required to make timely decisions. The ultimate architectural goal is achieving high velocity information. These are insights that are inherently on demand, AI driven, and continuously adaptive. Reaching this level requires upgrading legacy systems to a data ready framework built specifically for immediate, autonomous computing. This diagram shows the engine behind that framework, the continuous feedback loop, that enables decision systems to autonomously learn by closing the gap between prescribed actions and actual operational outcomes. Moving at the speed of an algorithm requires an architecture where the data inherently fuels its own continuous optimization. Advanced enterprise algorithms are only as intelligent and capable as the underlying data infrastructure supporting them. You cannot build an AI-driven, high-velocity supply chain on a brittle foundation of disconnected, software-dependent data silos. Organizations must standardize framework interoperability and aggressively elevate enterprise data to an independent asset. They must unify isolated logistics functions through centralized universal load IDs, and they must prepare the enterprise architecture to natively support full spectrum analytics and continuous feedback loops. Fixing the data readiness gap must be the foundational priority before any new AI or software deployment is approved. Mastering data readiness is the absolute path to transforming a blind, reactive supply chain into an autonomous network capable of real time, self directed optimization.
Hello, this is Raina McClure from SC Tech Insights. Thank you for listening. For more on this topic, click the article link below or go to www.sctechinsights.com for the latest insights on supply chain technology. Thank you and see you next time.